Good afternoon, everyone. I am Mervyn Betts, and this is Lee Allen. Today we're going to take you on a little trip, single-handed success story. What was really interesting about this story for me was that Lee sent in a request to our support group. And the request in the support group was, how do I script this, and how do I get rid of the X in a pop-up so the operations people can't get rid of it? And having no idea who he was, and knowing the city of Lethbridge, we'd lost a bid like 4 years before to him, I was very confused as to what the city of Lethbridge was actually doing with VTScada. And I think even Pat Cook had actually sold them the license and sort of snuck it through somehow. So it was a real shock. And so I went down and saw Lee and I said, what are you doing? He says, oh, you're here to sell me licenses. Yeah, he said, I am deploying in December and I should probably buy some licenses, right? So anyway, so that's what kind of got this all started. And so I'm going to let him take you on his tour today, and then I'm going to join in and talk about some of the second part when I went down this year again. And we looked at some other software and did some software installations. So with that, I'll let Lee Allen take the way.
Is it working? Loud? There? Okay, all right. I talk loud and get excited anyway. Thanks for coming. We'll try to make it interesting for you. And with that, we got a lot of slides to get through, a lot of info. We'll try to keep her moving. So that's us, me, Mervyn, and I'm going to tell you about the SCADA upgrade that I did for this facility. This is the wastewater plant for the city of Lethbridge in southern Alberta. It's the only facility in town. We treat all the residential, commercial, and industrial wastewater for the city. There's about 100,000 people there. It's also a bit of an agricultural hub for agri-food industries, and that means there's extra load that comes to the plant over and above what you'd normally see in an average city that makes it look more like about a city of about 250,000 people. I'm just trying to kind of set the stage here and let you know this is how big this system is, so that everything I say after this, you can take with however many grains of salt to decide whether this has any bearing on the scope of the projects you work on or not. The system that runs it, we got about 24 PLCs around the campus, running everything automatically. About 40 lift stations around town. The system has maybe 3,800, 4,000 tags, something like that. Fully automatic. We staff it from 6 in the morning until 4 p.m. and then everybody goes home and it flies on autopilot overnight and it calls out if it's got alarms. So that's kind of what the facility is. Myself, this is who I am. I'm a lifelong hacker, tinkerer, maker. I have a background as an electronics engineering technologist. Started my career doing circuit board repairs, transistors, resistors, whatnot. Did a little bit of consulting, moved into working for a small company that built automated irrigation equipment. And then about 12 years ago, I landed the job at the wastewater plant for the city. Like I said, I think of myself as a lifelong hacker. I got Wile E. Coyote there. I kind of see him as a bit of my spirit animal because I like how he's always making crazy inventions. Plus, I like how he can take a punch. The number of times that guy's had boulders dropped on him or been catapulted into a cliff and he gets up and walks away, I mean, I got to respect that. My role at the city, when I landed there, I said basically, let's just do everything in-house. I'd been doing programming and SCADA stuff, so instead of contracting it out, I said, I'm here, let's just do it. So it's pretty much everything's done in-house. PLCs, the touch screens, the control system network, license data radios, firewalls. If it's at the sewer plant and it runs code, it's my baby. So that's me. And to tell the story, I kind of got to go back to the beginning when I first landed there and saw what we had. Any good story kind of needs a villain or at least a good catastrophe. And this, for our purposes today, is going to be that. The software that was running their SCADA system when I got there was not VTScada. It was a different product from a different supplier. They labeled it as their enterprise solution, which after I started playing with it, I think that meant it's big, it's awkward, it's expensive, it was hard to use. I mean, this stuff was a nightmare to develop in. It's not like VTScada. There's nothing that's context sensitive. You want to add a display on the screen and show a tag value. You had to write a bunch of esoteric script code. Error messages were, I mean, in physics, they say you can't have a high pressure and a low pressure at the same space at the same time. But this stuff managed to simultaneously suck and blow. I mean, it was bad. It was bad. I got there, I spent the first few years getting to know what I had to work with, and at the time I landed there were already some upgrade forces at play. There were bureaucratic things going on that, for reasons I won't get into, I was basically locked into, okay, it's going to be an upgrade, but we're going to basically use a newer version of the same product, which at first I thought, all right, that's great, because this old stuff is not good. As I started playing around with it, I realized it's better, but not good. I mean, it was, to put it in context, imagine if you were me right now giving this talk, and you accidentally, suddenly, without warning, cut a loud ripping fart. That's not great, but it's better than if you also pooped your pants. That's kind of what we had here, is this was a nasty pant load of turds, and it smelled bad, but no mess. So we got that upgrade done, and they basically just took the old system and ran it through their conversion utility and gave me the same looking screens running as on their new software. And I thought, well, how am I going to get some kind of a win out of this? So I decided to tackle upgrading the graphics and the displays, because of the faults in that newer software, and there were many, one of the things it did allow was for me to import graphics images and display them. And I decided, great, then I can at least draw my artwork. I wanted to separate the artwork that I was creating from the SCADA software, and I wanted to make that, then I could make it be reusable in my touch screens and on some of my things like my Itanta displays that we'll talk about, or PowerPoint presentations, or just anything, right? I wasn't going to be married into the drawing software that came with it. That's what the original screens looked like. I don't want to throw any disrespect at the guys who built it that were there before me. They did the best they could with the tools they had, the knowledge they had, but it was very dated. You had the black screens with the, text that's different fonts, different sizes, neon colors. You got these kind of quasi three-dimensional bezels eating up a bunch of the screen. It had this weird symbol on a bunch of screens that I don't know what that ever did. It was just kind of all over the map, which this isn't, I bet some of the people in this room probably have seen systems like this, right? Stuff comes from the 90s, and that's what you get. About that time, in the 20-teens, that's when that whole concept of the high-performance displays started getting some press, and people were getting excited about it. And so I read about it. I liked a lot of it, about maybe 3/4 of it. I thought, that's a lot of good ideas. Some of it I wasn't as warm on. And I'm the kind of guy that I always got to take what I like and just steal it, and I don't tend to buy anything wholesale. But if you look at the displays, and I bet a lot of you are familiar with it, you got the more muted color palettes. You've got a very consistent way of displaying text. You've things that are off are dark gray, things that are on are white, all those good things that go along with it. So I decided I was going to kind of adopt a lot of that, and I was going to be a thief and steal what worked, but I wasn't going to be married to it completely. So I wanted to also at the same time figure out how the system was being used by the guys that operated it. When I got working at the city in the first 2 months, I decided to shadow one of the operators for a couple of days. So we were going out, washing weirs, bringing samples in, looking at SCADA screens, going around the plant. And I wanted to do that to get a feel for who those guys are, how they use the system, what their background is, so that I could kind of see it through their eyes, and if I'm going to redesign things, try and make it work for them. Like I've got Professor Frank here from The Simpsons, and he's giving this extremely technical description to a bunch of preschoolers, with this old push toy, and One of the kids puts up their hand. Any questions? Can I play with it? No. Just enjoy it on as many levels as I do. And he's pushing it back and forth. When I did that, then I realized, okay, the guys who are operating the plant, they're not process engineers. They're millwrights, they're mechanical guys. They understand how to get rusty bolts off of pumps, but they're not, P&I diagram symbols are not intuitive for them. I don't need to make them see it my way. I can try and see it their way. So one thing I want to point out here is I did find it very helpful to just kind of close that loop between I'm the guy developing the system, they're the guys using the system. There's great feedback. If you're part of a system and you're not spending time with the guys that are going to use the product, you're doing yourself and them, you're making your lives more miserable than it needs to be, because, man, that really helped. I'm going to jump ahead just a little bit. So here's an example of the old screens, like I said, and here's kind of where I ended up getting to, and I'm going to talk a little bit about how I got to this point. But you can see it looks kind of high performance-y-ish, but there are a few differences. One was I don't have strict P&I symbols. I tried to come up with graphics that I could draw easily that represented what the devices looked like in the field. Some P&I symbols look like a thing, and some of them don't. But even on my specialty equipment, I've got like a gravity belt thickener, I got float switches, these are all impeller pumps, there's some valves, right? It kind of looks like the thing that it's supposed to be. I got lots of embedded trends, I've got more muted colors, all that great stuff. One of the things that was important to these guys I found out is piping layouts matter to them. They're mechanical guys. So I put more visual emphasis on the patterns of flow with the pipes. I could have drawn those with thinner lines. If you look at the hardcore high performance standards, they tend to be, you have your devices and then there'll be just like a 1 pixel wide line between them. And I found that, I don't know, personal choice. I like it this way. My guys seem to like it this way. Your mileage may vary. As I said, because I broke the way I was doing the graphics away from, and I wasn't using the drawing tools inside of that SCADA package, now my graphics and everything I developed became reusable. So what I ended up finally building in a new graphics library, I could use those images in my main SCADA pages. I redeployed them in my touch screens around the plant. I could put them in my Itanta screens. Like I said, I can put them everywhere. And that became very handy and a big, big time saver. So the way I did that was I decided first I needed a good tool for drawing them, and that basically comes down to using a vector drawing package. So you got vector art, you got raster art. Imagine you're familiar with it, but just in case you're not. Vector artwork it's stored basically as a series of mathematical instructions, like when you're in school doing geometry and they say, go to these coordinates, draw a line this many units at this angle. It's like that. Whereas a raster image is just a grid of pixels, right? Editing things as a vector piece of art is extremely powerful because, like if we look at Marvin here, you can do things as you draw, you're not entering the mathematical coordinates, you're moving things around with your mouse and doing it fairly intuitively. In the background, the computer's figuring out what those mathematical instructions need to be to end up drawing that guy. There's good packages out there that do it. Adobe Illustrator would kind of be the spendy big one. I landed on CorelDRAW, Inkscape, GIMP. There are a couple of freeware ones that work well enough. So if we zoom in on Marvin, he's crisp as a vector image, and you can zoom in as far as you want. It'll always be that way because it regenerates that image at runtime with those instructions. Whereas if he's stored as a raster image, you zoom in, you just start seeing blocky pixels, right? This is important because, like I said, for editing, you want to be able to do it this way. If you want to grab his eye and move it around or change the shape of it, you can do that. Whereas over here, you're just going to be starting to recolor pixels and it becomes just horrible. Technically, you could do it, but why would you? Because it's like trying to write computer software with actual ones and zeros. It's just, that way lies madness. So after I had the tool, then I decided, okay, now I got to start to develop some standards. How am I going to draw all the devices that I want to draw? How am I going to build the library up? And it came down to, it's a different kind of artwork. You're not, like here I've got 4 pictures of people, right? here's like a comic book type of example. You got the more technical drawing, a video game, and then this little dude. He's the simplest of the bunch, so I'm trying to convey the most meaning with the fewest lines. To make it simple to draw, I want it to be instantly recognizable is my goal, but not realistic. Because if you're getting realistic, that means you're putting more work and flourishes into the artwork that aren't really, after you know that that's a guy, that's all you need it to be. He's pretty recognizable all around the planet as a guy, or a person, sorry, but he's not realistic. If you met someone that looked like that in real life, run away screaming, because, I mean, his head's not even attached to his body, right? So here's when I started drawing my devices. Here's some examples. Here's some pre-canned things that I stole from a SCADA image library, right? Pump, a blower of some sort, heat exchanger, boiler. Here I've got stuff I created. So my impeller pump, here's a screw-driven air compressor, generator, I got a boiler, circular clarifiers. The thing about this is these are prettier, I won't deny that. These are way easier to draw. There's a bunch of advantages to doing it that way. They're easy to modify. You can resize them, and that's actually important. I'll talk about that. They're cheaper to produce. It requires little to no artistic ability, which is important. Like if you can draw a mean stick man, you got enough chops, artistic chops to draw these. In fact, I'd say that's the sweet spot, because if you're actually artistic, you're gonna be tempted to put flourishes in. And that may be okay, maybe you're efficient at doing that, but again, like Glenn was saying earlier, you want to make your work maintainable. Someday you're going to be gone and some other poor schmuck's going to have to follow in your footsteps, and if you've done a bunch of shading and fancy stuff that he's not good at doing, one of two things is going to happen. He's either he's going to hate you and have to get good at it, or they're going to not do it, and now you're going to have inconsistency in the way your artwork looks. One of the things about drawing it this way is every plant, anything I've ever done, you always end up with some kind of special equipment. I don't care what kind of great canned artwork library you pull down, sooner or later, you're going to buy some piece of equipment that's not in there. Well, now you either have to try and make artwork that looks like that stuff, or have something that doesn't seem to fit with the rest of your system. Whereas if you've created it from scratch and it's just this simple flat stuff, you can always take something that's similar and modify it. So it leads to reusability, and it leads to possibly doing animation, which I know is a dirty word, especially in the high-performance world, but I'm going to make an argument for that in a little bit. One other thing I want to point out, a tip here, is make sure when you're trying to develop this stuff that it's something that you could display it with, say, twice as many pixels or half as many pixels, because if you're drawing this originally on your SCADA system and you've got a nice 4K 42-inch display, which should be your minimum these days, because, man, it's cheap enough now, why wouldn't you? And there's no substitute for having gobs and gobs and gobs of high-resolution pixels at your disposal. You can just lay out more stuff on your screen. It's easier to move the stuff around. You got white space. If you're trying to squeeze everything onto small monitors, if a client doesn't want to pay for the monitor, buy it for them. You'll save enough money in doing your artwork that it will more than cover it. But having said that, that's great. You develop all that, but then if you're going to use those things in, say, a touchscreen that's maybe only 800 by 600 pixels, now you want to be able to have that pump be drawn with fewer pixels and still look halfway decent. Otherwise, you're going to end up with, here's your touchscreen and your pump's this big. Well, that's not going to be great, right? So there's caveats to designing this stuff to make it efficient and work well. Glenn talked earlier today about technical debt, right? If you don't design things correctly up front, then you end up paying for that all the way along, right? So these are some things I found as I was thinking about how I wanted to develop this, how I wanted to lay it out. So in the case for animation...
I'm going to hop in here for a second
sure,
on that.
Yes, go. Sorry.
No, just on that topic, especially if using thin clients, try the first graphic you draw and then check it on your thin client, because usually on a project, the last thing we set up is the thin client, and it's so easy to do, and it's so magical. And if you have 4K graphics that you have designed, and you try to look at it a little display on a cell phone, you will find your graphics are a little bar on top of your screen sometimes, or else massive, depending on what's going on.
You do want to think, when you're laying this stuff out, you want to think about the resolutions you're going to be looking at it. I know in my plant, that I'm going to be, my SCADA screens, they're all the same. I standardized on 4K 42-inch displays, great. And then I break it off into other things when I'm doing touch screens or whatnot. But yes, we don't, if you had a module or a mobile thing where you're going to be looking at it on a cell phone, that's going to be, you want to think about that.
So get all your devices that you're going to possibly
Test.
use and try it. And then you
Yeah.
got the other guys in the field that are still on tough books. And they're like 7 years old. They're probably on like Windows XP. And they're going to try to get in and see your graphics.
Yes.
So make sure you get the client to give you a list of stuff that you're actually going to be touching, and make sure you try it all out after you do the first drawing or the first layout, before you draw 40 drawings or 100 drawings or 800 drawings, and find out that you have to draw a whole second set of drawings for low resolution stuff.
Yeah, the whole point of what I was trying to accomplish here is, again, to avoid that technical debt problem and make my graphics library truly reusable. And vector graphics are great to work with. Like I said, though, there's the raster format, and the thing is, most of the touchscreens and SCADA machines, they want raster format images because it's a lot quicker and easier for the computer to just dump down a bunch of pixels than to actually do all that vector math and draw and generate it. And if you're drawing however many things on a screen, that's extra load. So think of it this way. You're developing your artwork in a vector program. That's like, if you're a programmer, that's your source code, okay? And then the raster image would be like your compiled output. And you can compile things for different platforms. That's kind of the way I look at it. And you get the better performance that way, but yeah, you got to know what you got to compile it to, and you may end up having to make different versions of things to make it all work if you've got wildly different displays. But anyway, I wanted to make a case for animation. I think it's worthwhile. I think it's good if it's done right. And I go back to the high-performance display idea. They said, we're going to use muted color palette. We're going to use, the color red is for alarms. We're going to have specific cases for, they didn't say monochrome. They didn't say crazy loud neon colors are bad, therefore we'll go monochrome. They said we're going to use our brains and lay it out smart. If you make your screen so that everything's spinning and jumping around and you got munchkins everywhere, if everything's moving, nothing's going to stand out. But if you use animation the same way you use color, I feel like there's a really powerful communications channel there to try and signal your operators. If you're making things dark gray and white, that's great, but you can also add to it, right? I mean, when we look at these dudes here, it's the old Sesame Street thing, right? One of these things is not like the other. That's 2 image frames that I'm just stitched together in a little animated GIF utility, which I got a link to here, $30 program. That took me, so I drew this piece of artwork. Well, once I got a good flow going, a piece of artwork like that in my Corel Draw might have taken half an hour to draw. Well, now to grab part of it, slide it over a couple pixels, and export that again, that extra frame took me, and then to stitch it together in the utility, maybe an extra 3 or 4 minutes. So it's not terrible if that's the way you're doing it. So that leads to, can it be done cost effectively? And again, that's getting back to that technical debt thing. If you came in after the fact to a facility that all the graphics are done, and they're, especially if they're canned and they're shaded and they got a lot of detail, and people said, yeah, let's try animation, that could be an extraordinarily onerous task to try and, after the fact, put animation on things that were never meant to be animated. But if you've laid out and planned for it from the start, it becomes more of a nothing burger. So this page shows some examples of actual things on my pages that are animated. So I've got a macerator that's off. At the start of the plant, it chews up all the nasty solid things coming down the line. It's just a bunch of tines and things. Here's a pump. It's on, it's off. Fan on, running. Even float switches. Here I can add more meaning to it because, okay, that one's down and that's normal. This one's up and that's abnormal. I could have the reverse where I go, okay, normally that should be, it's a low level, so it should be up and normal and down is bad, right? So you can add, by combining different graphics and colors, you can add things to it. Here's a couple, again, of very specialized pieces of equipment that I never would have found in a canned library. Our gravity belt thickener and these grit snails for dewatering. And granted, this one I went a little crazy on animating all the little water drops and the turning. This was getting a little bit insane, but I felt inspired that day. Here's another thing I want to kind of point out is I don't think that making your displays visually interesting is necessarily a crime if you do it right. If you've got operators that are staring at the displays all day long and you've bleached all the interest out of it. If I'm giving this talk right now, I could be giving the talk in a very monotone voice, and I could give all the information with black text on a white background, and whenever I wanted to say something that was really important, I could raise my voice a little bit. Or I can have some goofy graphics, and I can make a joke about crap in my pants, and it might make this content that I'm giving have some context, and it might stick with you a little bit better. So that's my argument. Take it for what you think, right, if it's worth it or not. It wouldn't work for everybody and in every application, but I'm just saying consider it, right? How do I do it? So again, I kind of touched on this. You draw your first image and you plan for animation, and then you might have one or two parts inside that you're going to rotate a couple pieces, X number of degrees, export it. Do it again, export it again, export it. It took me maybe a half hour to draw that and another 5 minutes to come up with those guys, and then I stitch them together with this little utility, and I've got an animated guy, right? If you plan for it, you only have maybe, if you got less than 5 frames, that's great. Less than 10, still okay. There's different ways of doing it. In the old crappy Franken software that I had, none of this stuff existed, but it did allow me to import an animated GIF file. So that's what I did. That's how I first built this originally, was frames in CorelDRAW, stitching them together with this guy, and then I had a GIF that I could just bring in, and magic, it worked. If you're using VTScada, which you should be, it actually has an animated image widget in it. The Magellas touchscreens around my plant have something called an end state lamp. I call it a widget. I think they called it something else. It's essentially the same thing. So just to give you I'm not going to go into a lot of detail, but this is and a couple shots from my idea studio of an animated widget example. Here's that macerator, and basically all I'm doing is then on the background, at the back of the page, I've drawn a static image of the macerator when it's off. It's dark gray. I've got my animated frames that I'm going to put over top of it, and all you have to do with this widget is you say, point to this directory, that's where the frames are, run through them at this frequency, and then when there's nothing, you tie it to your status tag. When there's nothing happening, display nothing. So what happens is when the status tag is off for that guy, you're just seeing the static off image in the background. When it's on, this guy, I've moved it so that we could see that there was a thing there, but normally this guy would be lined up right over top of him, and you just see the running thing. So it's not bad to do. It's not that, once you get a workflow going, happens actually pretty good. If I was an integrator and I wanted to start doing this kind of thing for clients, I think I'd take it one step further, and I would put an application-wide tag in my system that's like animation, enable, disable. And then when you're reusing all these things, if you have a client that goes, no, we're not using animation, that's no, philosophically, boo, bad, okay, turn it off. They don't have animation. And then if somebody wants it, you turn it on. And if the guy says, no, boo, bad, and you left it off, and then 6 months later he goes, I want to try that, ask him how much he's willing to pay. Say, I'll get right on it. Go away for a month, do something else, come back, flip that bid on, charge him 3/4 of the amount that he offered, tell him that you worked extra hard and it's a deal for him because you like him. Or don't. You let your conscience be your guide. But anyway, great. I did all this work with graphics. I got animated stuff. Everything looks cool. Remember, now this is still like the mid-20 teens, and I was still doing it on this stinky beast. The graphics looked great from the operator's point of view. It was like a whole new system. The screens looked great. All the machinery that was running it was still this ugly monster that if you took him in the back room and looked under his dress, he was still a bunch of weird body parts that didn't fit together right. I wanted to figure out how to take this thing out in a cornfield under the cover of darkness, put a bullet in its head, and get on with my life, but I didn't know how I was going to be able to pull that off. And it turned out that the solution was actually baked right into it, because the product was tied very tightly to Windows Server 2012. And so at about 2020, I started looking more seriously at, oh, my operating systems are becoming end of life. All right. I call the vendor up and I say, yeah, I want to upgrade my Windows software. I can do that, right? They went, no. You're going to have to hire us to sell you new software. We're going to have to re-engineer everything. We have to convert everything over. It's going to be just like the last time. You're going to be the full upgrade package. And I hung up the phone and I went, screw that noise. And I started Googling different software packages. And at the time, I was thinking like Wonderware, RSV. I don't know. VTScada wasn't literally even a thing I'd heard of or remembered. If I'd seen it, I'd forgotten about it. But in Googling, I landed on the VTScada website and looked, hey, they got a free trial. Well, that's cool. Download it, start playing with it. It's easy to work with. It's simple deployment. I looked, they had the price list right on the website. Like, find another SCADA developer that does that, right? They're not hiding anything. It was inexpensive and it was very cut and dried. This is what it costs. To me, this kind of stuff, if it's one of those, well, if you got to ask, you can't afford it. To me, that's a red flag. Why are you charging that much? Why does it need, So I got pretty quickly sold on it. And I decided within the first week of playing with it, this is going to be what I'm going to build the rest of my career on with these guys. So I decided to be a little bit sneaky, talked over my plan with my boss, and we bought a new Dell PC. We bought one license that Merv didn't know about. And I just started building screens and tags. And that carried on. I sold it as proof of concept, but I mean, I knew I'm making the new system now, right? I set it up in my office right next to the production system. So I got old Franken software running here. I got VTScada that I'm building. And I just did it when time allowed, kind of like a tinkering hobby, low priority task. The plant's running on the new software. I don't have to push this out in 2 months or anything. And then I was also learning VTScada, just watching YouTube videos and reading the awesome F1 help documentation. That was how I did that through 2021, 2022. There was some benefits to doing that way. Very easy to verify the system. I got the new system and the old system, and I'm literally just, hey, I'm going to recreate that screen over here. I'm typing in my tags, making sure the scaling matches. So, I mean, by the time I got it built, I knew it was verified, basically. There was some cons to doing it that way. It extended the time frame out. I figured there's probably 3 or 4 months, solid months worth of my time to rebuild my application in VTScada. Doing it this way made it last about 1.5 years by the time I got it all done. So there's risks of extended time frame. The old system was still live and being used, and there'd be changes that I'd have to do. So if something changed in the old system and I had already built it here, I was going to have to go back and rebuild it here before it had ever even been commissioned. So if you were doing it this way, if you had a system that was in a constant state of flux, it's going to be hard to make any headway doing this. You need something that's kind of mature and stable, right? There was the risk of if it got sidetracked, if I just never got back to it, it wasn't ever going to happen and we would have had to farm it out. And then there was also some bureaucratic risk where there was a chance that the bureaucratic nitwits and the pinheads that wanted me, they're going to go, you did what? You bought a thing and a license and you didn't run it through us. And we threaded that needle and we got new stations set. When I was ready, we put up some new stations. They looked very much the same because my graphics work had already been revamped years before. So the screens looked 95% the same. Some things were touched up and improved and made better just because of the nature of VTScada. But it was set up the new station beside the old one, give them a little bit of a walkthrough on it, but I mean, the screens all work pretty much the same, and then wait to see if it's good to flip the switch off. And I was planning to spend a few weeks doing that. The operators, after like 2 or 3 days, were like, you can turn the old stuff off. So it was good. See, now there's a but coming. But the old system still fed data to an OSIsoft Pi server running downtown in City Hall. And that happened because there's a few engineers and managers that they don't work at the plant, they don't need to operate the plant, but they need some data from the plant once in a while. They might be working on a capital project or doing some reporting for the government, and where they're like, I want to know what the flow into the plant was every day for the past 5 years. Stuff like that. That's what this system did. The Pi system also was the long-term storage for historical data, because the old Franken software data would fill up and it would just fall off the back end. It didn't have really good long-term storage. So the workstations, at this point in the story, VTScada is up and running. The operators are using it. It's running the plant. It's live. The old Franken workstations are gone, but there is still a Franken server delivering data to Pi. That was a good news, bad news thing, because the fact that that old Pi server existed and had old historical data, I was able to then build a little tool where I could go in and vacuum up all of that old historical data that I wanted from it, and then put it in CSV files that were formatted correctly and ingest them into VTScada. So that was good, because then after I did that, my VTScada system was, like, say, fully commissioned and live at the start of 2023. But now it also had historical data from whatever we had before going back. And I went back a decade. I was like, that's good enough. So I did that, then pumped it into VTScada, and literally, I mean, here's the, if you, F1 help, search import tag history. This is the page that comes up. And if you were doing this and you followed that verbatim, it works just like advertised. So at this point now, we've got a whole new VTScada system, and it's got all the historical data. Kind of recapping, you had messy pant load of turds software, you had stinky turds but new screens that looked right, and then they got obsoleted because the Windows software was end of life, which allowed me to kind of blank slate the whole thing, and then I could go to VTScada, which is the Tony Stark, Iron Man, awesome leading edge tech, right? And that gets us to this point. So I'm just going to kind of recap here. The graphics, I've already talked about all this stuff. Vector-based source files, reusable artwork. Think about animation, just saying. We like it, but again, do you. When you lay stuff out, in the beginning, leave extra space on your displays, right? White space, because you're going to add things years down the road. If it looks nice but full-ish on day one, in 5 years, you're going to be like, oh crap, I got to break stuff off and make another screen, which isn't the end of the world, but I'm just saying. And to help with that, big displays in 4K, lots of large high-resolution pixels. Nothing will help you more than having that. And talk to your operators. If there's nothing else you do today that I said, just please, the projects that I was involved in before, where you'd show up to site to commission something and they've never seen the screens yet, and you're ready to bang it in and hit the airplane home, and they're like, no, we don't want that. Like, close that feedback loop. It will help you, it will help them, you'll save money, they'll be happier. The tag database, I haven't even hardly talked about that in VTScada, but I'll just very quickly, the way I migrated my database over, I only had like 4,000 tags. When I did the math, I figured I can type all of those in about 6 weeks. My old database was a dog's breakfast, and so I decided here's an opportunity, again, to kind of clean slate it, like I re-updated all my graphics. So I literally went through, I decided I'm going to have some kind of naming conventions, like Glenn touched on, make things concise and useful. And so it was literally just that tag, okay, I'm going to type it in, this is what it does, check my scaling, and I just one by one, it was a manual process. If you've got 800,000 tags in your system, that might not work. If your database already is reasonably good, maybe you can just run it through some kind of a conversion thing. This is what worked for me. It was a chance to review it, clean it up, trim fat from it. If you got a bunch of tags in there that nobody knows what they do anymore, might be worth investigating and see if you can get rid of some of them. The description tab in the tag browser, it's a really good idea, and to use it. You can see that I'm not making as much use of it as I could. The only caveat I'd put in there is if you're going to do it, be serious about using it, because I do a lot of, I create a tag and then I want to make something that's like that, so then it's, the copy, paste, rename, that's great. And then I forget to update the description field, and I have all these different tags, and they all, in the description, say the same thing. So if you're going to use it, put some effort in and own it.
And I'm going to give you a couple tips on top of that.
Go.
So one is Trihedral is a service that on a best effort basis, they will migrate your database for free when coming from a competitive product. it's fantastic. So make sure you're aware of it, take advantage of it. If you're integrators, you can take advantage of it. I mean, we don't ask who did it, just get them the files, they'll convert it, and you guys can do with what you want. The second thing is when you do descriptions, use a concat string in your descriptions. Especially if you haven't, you can export to Excel, especially your database. We can export to Excel, concat them, and it will just build the string up with the path and all sorts of things. If you build a proper concat statement, it gives you the tag name and possibly the asset, depending on how you built your tree, and that makes things very fast, because you can take a system like yours, and we can just walk in and concat them all the way down, and all of the descriptions was built, so you can have really nice alarm descriptions and things like that, right, for them. So those are things that as you kind of are starting to look at these things, there's a whole bunch of tools that are built into VTScada that kind of after the fact you can kind of go in and clean some of that stuff up. So
see, and that's one of those things, one of my points right here, don't let perfect be the enemy of the good. You could get paralyzed going, well, this is new and I don't know exactly what the absolute best way is, so I'm just not going to do anything. Make it better, move forward, find out later there was an even better way yet. Okay, great, and don't put up with mediocre if you don't have to, and be patient and be tenacious, because it took me basically 11 years to get rid of the awful software, but I did finally get what I want because I was tenacious, I was sneaky, I kept bugging the managers until they finally just said, fine, and let me do it. After all this got done, so I did just a couple slides here to talk about benefits. So technically, VTScada, I mean, if anybody in here doesn't already know, intuitive, runs well on low-cost hardware, runs on any current version of Windows, which was mind-blowing to me when I was dealing with my first piece of software that was not VTScada. Easy to do upgrades, inexpensive to deploy other stations, easy to do backups, easy to add redundancy. You can segment your network and put security measures into it real nice. You can firewall the crap out of things between servers. It uses one port. Go for it, right? The tag browser's nice. The change set files are pretty awesome. They've talked about that already a few times here. The power of it, that elegant state-based machine that is VTScada means that it'll run. I mean, I got thin clients running on $400 mini PCs and it runs fine. My main developer stations could probably run on those same machines. We just said, you know what, let's at least buy a halfway decent desktop machine, especially if you're developing and I'm running that and I'm running CorelDRAW and I'm doing this PowerPoint presentation and things. I might get my CPU usage up to like 15% instead of 9%. Costs. So anybody in here that's in charge of any kind of budgets, this slide might be interesting. That original upgrade that I was forced to do, upgrading from the really horrible software to the less horrible software in the 2015, 2016, they charged us for my department. It was a little bit north. I don't remember the exact number, but it was like $500,000, maybe a little bit more, maybe 10 grand. I don't know. It was that neighborhood. And that did not include getting new screens redesigned. I did that. Right? They were taking the old screens, pumping them through a conversion utility, putting their new software on some new servers that included hardware, the Windows licenses, coming down, commissioning it all, and it was going to be the same old 90s black neon screens with funny text, just running on a newer monster. I did that upgrade on the graphics basically outside of and beside of that SCADA upgrade. So then when 2022, 2023 upgrade VTScada, at the end of the day, 35 grand on some licenses and about 25 grand on some hardware, so you're 1/8 to 1/10 the cost to do that. And the way it was done was cost-effective, intuitive software, VTScada, simple, easy hardware. Like Glenn said, you don't need big servers, right? Depending on your installation. If you're building a system that's got like 10,000, 20,000 tags, like I was at 5,000, desktop machine will run everything just fine. Buy a few of those, you're good to go. And then in-house development. I could either work for the city and be the contract administrator, hiring an integrator and explaining to them how to build it, or I could just build it. And because I'm a wirehead, Wile E. Coyote, backyard inventor nut, I chose that. Technical drawbacks. There weren't any. I know this sounds like a hyperbolic and I'm being a VTScada fanboy, but understand, I come by this honestly because I suffered with that other software. I was like, when I went there, I'd had a couple of decades of controls experience before I got to the city, and when I saw this stuff, I was like, what? right? There wasn't anything in the performance, the reliability, the development environment that I was working in from the user's experience. There wasn't anything in the old software that it did better than VTScada. A few things were like comparable. Most cases, VTScada was miles ahead. So just think about that. It was about a tenth the cost, and it wasn't a tenth the cost and settling. It was a tenth the cost and getting something that was in every measurable way, and I'm not exaggerating, as good, in most cases, far better. So I'd call it a win. So at this point, that's all great. VTScada is up and running, everything's good, we got the historian, but there was still one thing, and this is going to lead into Mervyn now. We had that old server sending data to that Pi system downtown for those engineers on the corporate side. Still needed to get rid of that beast. So now this isn't VTScada, now it's Pi, OSIsoft Pi, and I wanted, because I'm changing this out and it does, I don't want to set it up to talk to, I don't want to set VTScada up to talk to Pi. Now I've got to find some replacement for that. That's where Itanta comes into the story. So feel free to hop in anytime, but until you yell, I'm just going to keep going because, yeah, I'm like the Energizer Bunny on this. The idea was going to be we bring Itanta in, we're going to largely be giving users dashboards that will be served to them instead of them just having a column of data in an Excel spreadsheet that then it's up to them to make charts and graphs. They could still do that if they wanted to, but why? The Pi database was replaced by Itanta, and at that point, then the old SCADA server could be fully decommissioned, and I could actually totally say, that's done. I never have to go back to that. There was a bit of resistance to doing this because there was a user or two on the corporate side who were like, well, yeah, dashboards are fine, but I still want to be able to do my spreadsheet. Sometimes it's the devil you know. Sometimes people got to be, like I say to Chase a lot, sometimes people got to be drugged towards success, kicking and screaming. I just kind of kept hammering him and going, well, explain to me what you need. Why do you need this? Why do you need to be able to pull that up? And in the end, again, he conceded and I got what I wanted. And where we're at now, I think, is as good or better, but there's going to be more improvements coming yet that's probably going to blow his mind. I wanted to just talk about this slide briefly where you go, okay, well, yeah, Itanta, that's neat. How does it fit, right? I mean, VTScada is this thing for visualizing data and doing stuff, and Itanta sounds like it's for visualizing. How's it different? What's different about it? Here's the way I use it. Got my industrial control system down here. This is the plant running VTScada, all those things. We've got the corporate users over here with all their scary things. They're watching YouTube videos and emailing their friends about what bar they're going to go to, and occasionally they want to reach over and get some data that's concerning this plant. So this is how this works. I go through a firewall to a runtime, read-only application on a mini PC in a DMZ. And then I've got a mini PC doing my Itanta server. This guy uses that REST data connector that I think Keith was talking about it in his session. And it's firewalled. So I got a firewall that's locked down real hard. I got a read-only runtime thing here. I got another firewall locking this down. This connector's read-only as it is anyway. So these guys now, they can go through this guy, and I've locked it down saying only certain people on certain machines can access this guy in this certain way. And that's as far as they go. They never touch this. So Itanta gives me some separation, some really nice separation between that corporate side and my side. They can still access their data. And if they were to compromise this, if this got hacked, it's, okay, now you have to get off your chair, drive over to the plant to see that data that you're looking at. So it's an inconvenience at most, and it won't be that hard for me to rebuild this thing once I've got backups. So I restore, plunk a new thing down and do a bare metal restore, and then basically just let it refill up its database from the REST connector. My attitude is, thou shalt not touch my sweet precious with your nasty, dirty, filthy internet-connected computers. And that's how I make that happen. So Itanta, that's kind of what it looks like, right? We got some more slides about this, but you end up with these dashboards, and these are all drag and drop. You don't write any actual code for this. And then your data source manager. This right here is worth the price of admission to Itanta, because you set up your data connector in Itanta on the server, and you say, okay, I'm going to connect to this VTScada machine, and here's the parameters. I've sanitized it and knocked out some IP addresses and stuff. Once you do that, you start building data sources. And the way it works is you basically just go, get columns. And the REST connector, it populates on its own all the stuff that's in your VTScada database. You aren't manually creating tags and then linking them over to it. It comes, it populates, and then you can, and the hierarchy tree, those are my context tags. It pulls all that in, and the tree is filled in correctly. So I can go, I want to grab everything from the touchscreen 2B primary clarifiers, or I want everything on the report data, or I want to drill down under report data to the alarm page for plant stuff that's under there, and I want to pick these, and that group, or whatever. Hit the button. Those come over here. I say, grab it at this 60-second intervals starting at this date and time. That's cool. From this archive, go. And that's it. So, and you can build lots of data sources. So I've got 40 lift stations around town. I have a data source for every lift station. I didn't need to. I could have had one data source that was the entire VTScada database, but it's got 4,000 tags in it. And when I'm doing things on my dashboards, I'd like to be able to go to that data source that's got a level and a flow and a couple pump status. You know, it's just now I'm searching through this many tags instead of that many tags. So it's an organizational thing. You can do it however you want. But every time I use this thing to do this, compared to what I was doing with Pi and the old database, I get giddy still, because this is like, you don't realize how much this saves your life. So that thing's great. Itanta dashboards, there's a few examples. Again, it's all point and click. Security in Itanta, you can be coarse or you can be super fine grained. So you can go right down to a dashboard and say, I want this user to be able to view that chart, but not that one. Maybe he can add filters to it. Maybe you want a user who can create his own dashboards. You can set them up to do that. So do it however works in your organization, right? Most of my guys, it's you can view stuff, you can add filters to it to view it from different time frames and stuff like that. So now that that's done, here's an example of one of my lift stations, 39th Street lift station. If you're at the plant sitting in front of VTScada, that's what 39th Street lift station looks like. Fair amount of detail. You can see the levels, pump statuses, what the switch statuses are, generator, power, float switches, all those good things. You're looking at that same site as a corporate user, you're seeing Itanta, much less data I've put up here. The pump analytics, how many starts, how much of they each ran, has there been any activity on the high level switch, and then you've got that same kind of trend chart. Here's the level going up and down, and the pump statuses. I mean, it's a lift station. It's basically a big toilet, right? It fills up, it flushes, it fills up, it flushes. So, a lot less data being provided here by my design. I could have put all kinds of, I could have made a screen in Itanta that looks like that. I chose not to because one, those users don't need that level of data, and two, it's unnecessary to be, again, more work that I don't need to do, and it also kind of gives me that layer of obfuscation between, if somebody did get onto the Itanta server and start looking around, there's a lot less detail here if they were trying to fingerprint my system and do all that nasty cybersecurity stuff. I mean, you could argue how serious that benefit is, but it's a thing. So that takes care of my talk about Itanta, and then I could either bail out here or we can jump ahead, because I've got a couple of other small projects. Keep going? Okay. So now, Itanta, VTScada, all that stuff is handled. After all that was done, there's a couple of small projects that we just thought were kind of interesting to touch on. This is, now we're moving forward with all new territory. We have a dump pit at the front of the plant. We live down in the river bottom, as most wastewater plants do. And usually what would happen is you got a truck driver that's going to come down, he's going to dump some sewage in this grate here. The way they did it for decades was the guy would have to drive down around the hill up to the plant, get out his truck, walk in, tell one of the lab guys, I got 500 gallons, 5,000 gallons of septic, I'm going to drop it off from XYZ company. And then they write it on a whiteboard, type it into Excel later on, cut and pasting, doing all that, very manual. Get in his truck, drive around, come up here, dump, go away. So then they wanted to automate some stuff. So we put this little fiberglass hut here that we had laying around, and inside that we put a touch screen. And so now what happens, the truck driver comes down, pulls up there, goes to the touch screen, and there's like 5 pages, little menus. First one, each one of these basically represents a memory analog tag integer value in VTScada. The touch screen, you're going to push one of these buttons saying, I'm the truck driver for Drain Master or Roto-Rooter or whatever. You enter a value, it gets encoded as a, maybe this button gives you 10, that's 20, that's 30, 40. Each one of those, it's a number that goes into a register. Next screen, here's who I'm dumping on behalf of. Here's what I'm dumping, here's how much I'm dumping, the gallons or the cubic meters. And then so at this point, these are all being held in the touchscreen memory. I haven't sent anything anywhere yet. They're being held there, and when everything's golden and the system says, okay, he's entered all the values I need to know, you press enter. What that does is, as a group, it writes that to VTScada as analog integer I/O tags. They all come in at the same time, or very much the same time. And it holds them there. It'll say here, okay, record's been created, and the entry's locked. It'll just hold you on this screen for like 3 minutes. Effectively, what that does, so in my database, I've got these tags here, and if I look at them, I've got like dumper, bill to, record day, record hour, record minute, blah, blah, blah. So they're just those analog values. So what will happen is, if we look at it, these values all get entered at the same time. They're there for 3 minutes, and then they all get zeroed out. The next guy comes along at some point later in time, does another dump, and another record gets entered. By just putting the values here, waiting for a few minutes, and then taking them away, I've essentially now that's being tracked in the historian. VTScada historian's doing all my hard work for me, because now all that stuff is entered at the same time, it gets cleared at the same time, and it's date and time stamped. And then I can come from here and generate a report from it, so then that can give me an output that's basically just a CSV file. After that, I have a little Excel Visual Basic tool that I built so that this will pull that data in, format it, and re-encode or decode. This value was a 10, that means that's AgriPure. This value is a 20, that means that's Blue Velvet. These are the values. It comes up with a summary, and you can go through each of the pages and say, okay, for this dumper, here's what they dumped on this date and time. This is how much, every record. They can enter how much to bill. What used to be an extremely manual process that literally involved whiteboards and guys figuring this all out, now it's basically completely automated, other than that once a month, the lab manager will then go into this page, he'll run the report, he'll run this utility, go import the data, generate the report. So it's down to less than a minute now of his time. So that's what that project was all about. Okay. And then I thought, man, you know what would be cool is to have a good reason to learn scripting code, and I don't feel like going up to a course. I'm going to just annoy the tech support guys at BETSM and ask them lots of questions. And I have an idea for something that I want to build. At the back door of our plant, we decided to put another big 4K 42-inch monitor, just kind of mounted it to the wall, and staff scheduling. We got some plant leads that want to, they schedule who's doing what, throughout the day. And people were always like, man, I'd sure like to have an interactive or a thing that's up to date, because it's always whenever they'd print out the schedule, right? So now these guys, in another Excel tool that I built that's on their desktop, they can run this little scheduling tool that comes up with basically a chart like that with drop-down menus, and they can go, these are the plant employees, these are the days starting from today, so then they can fill in, okay, Petter's doing this and this and this and this, and then he's off those days, he's doing this and this, this guy's doing that. They can tweak and tune that, and what that Excel tool does then is it's the tool to let them do that, and it also then generates another PNG image file, just another raster image, dumps it to a directory that a little mini PC can, running VTScada Lite, so it was free to do. I did this with VTScada Lite. It picks that raster image file up and dumps it here. And so then whenever they make, and it just keeps picking it up every few seconds and dumping the image down here. So now they're in their office updating the schedule, and when you walk in the back door, here's the updated schedule, right? Works like a treat. There's nothing the operators can mess around with here because it's just a static image file. What is interesting, when I was first figuring this out, I thought, you know what would be wicked cool is if this big 4K 42-inch monitor was a touch screen. course, you can't, I don't know if you can buy that. It'd be stupid expensive. But like Wile E. Coyote had Acme, I have Amazon.ca. I went on Amazon and I found for about $350 this little device here that's basically a bezel. And then I 3D printed these clamps, and you clamp this bad boy on here and plug it in, and it basically replaces a mouse. And so now when you touch on the screen, it turns that 4K monitor into a big touch screen, and it works really good. I was surprised. There's no calibration. It hasn't drifted. It works. This page, there's nothing for the guys to do except there's a button over here that says truck schedule. They can press that, go on to the next page. Here's a bigger shot of what that schedule looks like. But anyway, next page, we got 4 trucks that anybody can sign out, drive around the plant. And again, it was clipboard right down on it. We're supposed to track all that. So what I built in VTScada, this is the page where I did all the scripting. There's 3 parts of this page. Over here on this side, using that touch screen bezel, you basically come down here under person, you pick, who you are. You press this, you'll get a drop-down menu, Lee. And then where do you want to go around town? There's north side, south side, west side. You pick the truck that you're dealing with. Oh, sorry, that's how it works. There's the truck, there's a truck, there's a truck. Person and where are you going? Plant, other, whatever. So you touch who you are, you go to which truck you are, who you are, where you're going, and then hit the sign out button. And that's it. You've signed a truck out. This truck right now is signed out. That's how that part works. The middle part of the screen then is a grid that basically shows you, okay, who's had what truck and where have they been? This is starting at, these are the trucks, the columns, 4 trucks, 4 columns. And then there's a grid that starts at I think 5 in the morning and goes till 8 at night in 10-minute increments. And so when you sign a truck out, as the time of the day goes on, you'll just start getting entries here showing Ross has the truck and he's doing sample run. And then Tyler has a truck here and he's doing suppliers. And then I color-coded it depending on the person that takes it. I just pick colors randomly because it makes it a little more visually easy to interpret. So now you've got a grid that shows who has what truck throughout the day. And then we wanted to do one better and say, okay, a lot of times occasionally we'll get a ticket. I shouldn't say a lot of times. Occasionally you get a speeding ticket or traffic ticket come in. The plant manager has to go, okay, which one of these yard apes had this truck on that day at that time? So that's where this magic came in. I call this the time machine. So you can enter over here, you can put in what year, the month, and the day, and then you turn on the flux capacitor, hit that button, and this, through the magic of time travel, swoops back in time to that point in time and shows here's what the grid looked like for that day, right? And then he can go give that guy crap. There was a ton I had to figure out to make the scripting work in this. I mean, for me, it was a ton. For somebody who's actually a scripting guru, it probably would have been a day or 2 of work. And I wanted to give Paul Bailey and Tyler Wheeler a shout out because I annoyed them with esoteric questions figuring out the scripting, but that was a fun project. So now, lab stuff. This is what we're pointing at now. Chase, right there, he's my protege. He's a biologist working in the lab. He's been there for about 6 years now. And just in the past year or so, he's half-time now starting to work with me doing automation work. And we want to do massive amounts of automation in the lab. So wastewater lab doing our testing, and everything in here is clipboards and pens, and it's write it down, go over and type it into a spreadsheet. Maybe then you take that number from that spreadsheet and you copy and paste it somewhere else, or you export that file into another program that does some calculations, and then you copy and paste that back to another spreadsheet and run some more. Touch the data. I think sometimes we said it was 5 times, which is insane. You should be touching the data 1 time. So we came up recently with some rationale for how we want to start doing some automation in there. We want to improve the quality, repeatability, traceability of the lab data. You don't have people touching it and transposing numbers incorrectly so often. Quality drift from the control charts. I don't know what that means. These guys have to talk about it.
Yeah, Chase, do you want to talk about control charts, or? Which was really educational for me when I heard what a control chart was.
Yeah, so control charts, basically in a lab you have to basically show that you are creating data that is what it is. Like, you can create data, but it's just a number. You have to back that up with historical numbers, like looking at a standard that says, yes, we are achieving a 90% or 97% accuracy. So what most labs do will be to collect like a standard. It's a known value. You test it and you compare it to the known value. So after time goes by, you can have a historic line or a trend of how that data is coming in. So say you can look back in time and say, okay, when we were doing our best work, our values should be within this statistically determined range. And if you start drifting out of that, then you can say, okay, well, something is going on and we need to start looking at troubleshooting our issues. So things like, say the lab manager comes in and says, let's get our quality up to par, let's really like bring it together, and all the lab staff say, okay, yeah, and they do really good. And then they do real good for 6 months. You get a good, nice, solid line that's in between the ranges that should be in. But after 6 months, guys get sloppy, they start cutting corners, and that'll show right away. It'll go out of the line. So what we're kind of working towards is building that system within VTScada so that alarms can be sent out to the lab manager to say, hey, there's an issue. Take a look at your equipment, take a look at your procedures, how your lab technicians are running, and start kind of bringing everything back into focus. So
you kind of baseline what your numbers should look like.
Yeah.
And then see if it goes weird.
Yeah,
If
exactly.
I understand it right, it can go both ways, because you could have numbers that get too erratic or they could get too perfect.
Yeah.
Because you got somebody fudging some numbers.
Yeah, there's a natural flow to values and numbers, and it's easy to look at a trend of those values and say, well, that's not exactly how it should be. So yeah, we're working to build that into our system. And another problem is lab data lab data is constantly outside of operational data. And in the world of wastewater, like, you have this giant microbiology environment that relies on a lot of lab data. So bringing that lab data in with the operational data and getting that data out to the operators as soon as the lab workers make it, it's going to be a real key proponent to bringing operators up to speed with decision making early on in the day before.
Be more reactive. Because
Yeah,
all this biology process,
real-time data.
it takes, you make a change, it's not immediate, right?
Yeah.
It's not like changing a pump speed to see a pressure change. You got to make a change and then wait. So anything you can do to shorten that time cycle up is going to help.
So thank you.
So yeah, here's an example, right? Doing some pH work here. You got a machine here on the bench that you do testing, and like I said, it's a clipboard. So what we're doing now, this is the first station that we're basically building up, and it's ready to be commissioned now. Chase has built it, and he's going to be basically doing it as soon as we get back after SCADA Fest. So now we've gone from the chart, the paper chart, to it's going to be you're entering it into a VTScada screen, and it's a thin client that when you boot that guy up, it basically, you could still pull up all the other SCADA screens, but it's going to boot up to this screen, because the idea is going to be you only ever are doing one thing at this workstation, and then eventually we're going to have more workstations. At this station, this is the screen that comes up. This is how you enter the data. When you put something in, and if it's outside of that range that Chase was just talking about, we can, again, alert, alarm, do things that before you just recorded the number and then you went and transposed it and maybe mixed a couple digits up because you got a touch of dyslexia, and all that stuff happens and there's nothing catching it. Whereas now we're going to be able to start tracking that stuff, right? So that's pretty exciting to start to be able to do to the lab what we've done with all of the control system stuff.
And what they're doing that's quite interesting is they've made VTScada their one source of truth. So they've decided, because they don't want people fat fingering stuff, but their analytics and things get done up in Itanta, or will get done up in Itanta.
Yeah.
So they're starting to build this sort of ecosystem where they always make sure that they are actually loading the data in everything. It's not something, normally lots of times people will load the data, manual data will go into a separate system, and you might bring it and aggregate just the SCADA data back in. But because of the limited number of systems they have, and because Lee's a control freak, it will allow them to actually control everything that goes into the system.
There's a couple more sub-screens for the pH station. And then, yeah, okay. The next part, we have another thing that'll be the next treat is the settleometers. They basically bring samples in from different parts of the plant, and they fill them up with basically wastewater, and then they time with this timer how quickly this stuff flocks together, and you basically have it settle like a blanket. And they time how that settles, and they record it every 5 minutes on a piece of graph paper. We want to Chase. The first step is Chase is basically going to allow them to enter those numbers on a touch screen, which is a step forward. But the next cool part is, so here's a, whoops, sorry. We're going to automate that, build an instrument. Again, I got Amazon.ca. So some photoresistors, an LED strip light, couple of Arduinos, a few other parts, some 3D printed parts. I was able to get myself a cool 3D printer at work because I'm building this thing. Cost of the instrument, I figured when all is said and done, is going to be about $300. This is proof of concept. This won't ever actually be in the lab, but I'm testing, and then we'll redesign the physical structure to work properly. And it works. I was 4 to 20 milliamp output going into a tag in VTScada, and it works like a treat. I'm going to I'll do touch-ups. I'll add more photoresistors so there's some overlap between them and all those things. But yeah, we're going to automate our... Chase likes it because I get to bring buckets of sewage back into the office. And he's like, man, I thought I was getting out of the lab. And I'm sitting over there eating my sandwich right next to it. And he's like, oh, you're disgusting. Okay. Thanks. Sorry,
No, we're going to keep going. This is great. No, we're going to keep rolling here. So one of the interesting things was when I went and talked to Lee after he had bought his VTScada licenses, we went down, Prasad and I, who was the president of Itanta, went down and talked to him and gave him a demo, and that was all great. And I said, you really need to buy the software. It's going to make a difference. It fits in with your philosophy, especially having something that's outside of his network that other people can bang away at and don't need a high skill level to work with. So Harshad and I went and saw, and Harshad's sitting here, he's the CTO of Itanta. We got on scene, and I said, so Lee, what do you want to do with Itanta? And he goes, I don't know, you tell me. He said, you told me to buy it, so I bought it. So that's how we started. So it's been very interesting. It provides separation between control and operations and the engineering administration and other consumers of the data. So the cool thing about that, again, is you can be the secretary of the mayor and configure Itanta. The risk is very low. To have somebody touching your SCADA system and going into your development, and I mean, you could put VTScada out as a separate application. You could do lots of things with it, but it's so easy to use. The training's like about 4 hours, right? So you have people doing things that are really important, they get the data that they need, and they don't have to deal with worrying that somebody's going to crater your system. And it's really easy to rebuild Itanta. If they crater it all you do is go back and suck all the data back in again, and Itanta's right back where it was before.
Do you want to take
No,
some
I'm good.
quick?
Oh, you're going to give me the...
Yeah, go
Which
ahead.
one's the...
That one, right there.
That one?
No,
That one.
this one, that's forward.
Oh, forward. Okay, good. Okay,
There
cool.
you go.
Got it. Okay, so training's minimal. Obfuscates the SCADA system. Lee's an absolute security nut. Like, he just does not want anything touching his network. He and Chase are actually the only people in all of the city that actually touch VTScada other than operationally, right? So nobody else does any development on it. The control charts for the lab quality, which we talked about, and it's outside the firewall. This is what Itanta scope was. It was replacement of OSI Pi. This is a big deal, and a lot of people pay a lot of money for OSI Pi, and it's a great piece of software, don't get me wrong. But also to spend $1 million plus on a piece of software and then pay $60,000 a year support, we weren't in any kind of numbers like that. I mean, we were $10,000, right? And support agreements like $33,000 a year, yeah. So, I mean, it got rid of the DMZ proxy server for SCADA analytics, integration of lab data, so we got rid of Allmax, and they're doing a whole bunch of interesting things now. Now that the SCADA is solved, they're going to start working more and more with the Itanta stuff. And one of the really, really neat things that he did was he went and had a discussion with one of his people that's consuming the data on the pump station. And you can hop in anytime if you want to, but...
Yeah, so there was one of those users that used to use the Pi data, and he liked to monitor the flow rates at a few key lift stations around town. And that was useful because if the flow rates started going up and you didn't expect it, maybe you've got a valve left open, maybe there's some kind of groundwater or something's leaking, or if you're pumping a lot more to do the same amount of stuff, maybe your pumps are worn out or not pumping right. So there's diagnostic information that he gained from that. So we were able to basically bring all that data back in through the Itanta screens now, and he can do that same thing. And we were identifying things quicker and easier because the Itanta pages are interactive. When you scroll around with your mouse, you can see the values. And so it was, yeah, it worked out really well for him.
So this provided a chance for a catalyst for change. And what it was Lee was willing to go out and talk to his stakeholders and say, what do you need? And all they were getting was 15-minute data, I think, before. Is that correct?
Yep. And also the way it was being calculated before was the engineer who came up with the idea who said, I want to be able to do this. This would be cool. He didn't come down to the plant and work on SCADA, so he was just trying to do it based on like flow rates. We didn't have a flow meter. He was calculating a flow rate based on how quickly the level would change in the vault, which is fine. That's a great way to do it. You know the geometry of the vault, from this point in time to this point in time, it's got to be this kind of flow rate. Problem was he's getting the data once every 15 minutes and there's latency delays in the radio network. So now you're doing something that you need critical timing on and you're not getting good timestamp information. So his flow rate calculations were off. So when he never talked to us about it. He just did the best he could with what he had because he wasn't thinking
And he'd done it for 30 years probably. I mean,
yeah,
Lee wasn't there.
Quite a long time.
Yeah, I mean, a whole bunch of things happened, right?
When the thing came up where I said, I'm going to be getting rid of Pi, I need to know how you guys use the system. And he said, well, that's one of the ways I use it. And when he explained to me what he was doing, I went, okay, we can totally do this, but doing the calculations in your Excel sheet at the end of all of this is not the way to do it. I'm going to go to those lift stations and I'm going to put the flow calculation in the PLC at the site where I can tell to the 10th of a second or whatever, this is when the pump started, this is when it stopped. I can do the calculation right there at the front. Then I'm going to ship that through the radio network and have a flow reading. Now we've got, instead of the flow reading being calculated in his office downtown at the end, it's being done at the start, so now we can read it on the touch screen at the site. We can see it in a SCADA system, and it gets pumped through to him, and he's got much better quality data. So there was a change in just the way the measurement got achieved.
And it did not occur to him at the top level that things could be better.
And I didn't know he needed that.
Correct. So it's interesting when you change. I mean, the price of the change was not very expensive for them, but it creates this whole environment that they've gone through to reanalyze the way they do things. And some things weren't possible 30 years ago when they first would have put this system in and then just keep repeating the same things. And it's interesting what Lee did with his tag names. He changed them all to make them standardized, because otherwise you say, pump's supposed to shut off but doesn't shut off, sometimes starts tag, and it's useless to anybody, but that'll just be through the system forever once that goes in. So, Itanta, we've been talking about it, we don't really know what it is. So, they're getting started with Itanta, and this is pretty exciting. But Itanta is a whole bunch of things. Number one is no code. So they're basically widgets like VTScada. You drag and drop them, you configure them. They're pretty quick to configure. Again, an introductory training in Itanta is a few hours. 4 hours, let's say, and you can train almost anybody that knows how to use a computer and a basic mouse how to get data out of Itanta. We connect to a whole bunch of systems, VTScada, Rockwell, Siemens. You'll see here we have the data acquisition, which we'll talk about the connector tool, and it's probably the only thing that some technical intelligence should be applied to. I mean, you might create trends and graphs that you aren't useful, but that's okay. Trial and error, you might figure some pretty cool stuff out. Data aggregation, so everything comes together in a solid database at Itanta, multiple systems, including mobile data and form data, all sorts of things can be brought into there, and then we come down to the data visualization tool. And then finally, we have all these output formats. So we have mobile output, email, PDF, you can output it to a CSV. So the same thing that they were doing before, mostly with their Pi system, was they were using it as a CSV generator. That was mostly what they were doing with OSI Pi.
And storage, long-term storage, which Itanta also does for us there.
It's a historian.
We're long-term storage in VTScada, but that's the long-term storage on the corporate side.
So, some key features. We have a formula builder in Itanta. We continue to evolve that. It's going to get more and more advanced as we go along. No-code dashboard builder, a forms interface, so you can build custom forms for people. Makes life really easy when people have something to fill in. I think within probably a couple of years, we should have QR codes and being able to snag forms. Every time you see Harshad, nail him down for a feature request or there are things that you want, get him to give you a date.
And he just goes,
yeah. Reports, data connector, and app with offline entry. So one of the concepts of Itanta is the citizen developer. Citizen developers are domain experts with limited coding knowledge. So they're subject matter experts, but they might know nothing about VTScada, nothing about Itanta. We want them to be able to get their data, because otherwise you end up with these projects, a Power BI project or something like that, and I have to say as an engineer, I want to know run hours and all the rotating equipment in the facility. Go, great. And then IT comes up and says, we need to get an estimate. You go, great. So the guy builds a project up, and a couple months later, he gets an estimate out for the project, and he's got a Power BI builder in there, and he had to build a new database because there wasn't one that existed, or he's got to buy something in the cloud, and you end up a couple $100,000 into it, and you get your stuff like 8 months after, and then the guy says, I wanted the rotating equipment. He goes, well, actually, I was having a problem on one of my pieces of rotating equipment, and I really just wanted to compare it to some other things. In 8 months, we actually replaced the pump, so I really don't care as much as I did before, and all that kind of stuff. So the citizen developer allows them in real time to become somewhat enabled to get their data, or at least you can have somebody who's an expert. They can just go sit down with them and say, hey, what do you want to do? And they'll go, I want this, I want that, I want that. Great, and it's all done. Citizen developers can create dashboards, reports, don't need any programming expertise. Faster time to market. So we want to empower people to get data, and that's where we are now. This is about the only thing, the ease of the connector tool, that I would say somebody with some skill level should probably be involved with, because you set polling rates in here, you pick protocols, and you saw where Lee had showed you how you actually just snag the data. But I actually have a 27-second example here. And we kind of did it in fast time, but literally, if it takes you a minute, I'd be surprised, right? So all this is doing is picking the connector tool. It picks VTScada, it picked the REST interface, that populates as Lee said it was. Boom, we got the data, tells you how fast it is, picks the time frame to go back to, and a collection name, and you're done.
this is the thing when I was talking about it before, the data source manager, I still get giddy when I use that thing compared to how hard it was to make tags in the Pi system before.
So it's very, very easy to use. It's very, very intuitive. And that piece is the only thing, like I said, because we're tag based on licensing, you certainly don't want somebody blowing out all your licenses, which you can always get rid of. It's not a big deal. But there's a lot more flexibility in philosophically treating Itanta differently than you treat VTScada. What also was up there, actually I should probably go back to, We also have drivers in there. So we have Modbus, Ethernet IP, Siemens drivers, OPC HDA. We connect to a lot of different things, and if we don't connect to it, we will work to connect to it. MQTT, Sparkplug-B, all sorts of amazing things. You can see all the different systems that we also connect to, WinCC, Wonderware. It is intended to be that sort of data aggregator for everything that you have in your system and bring it all together in one unit. And it's very cost effective. And currently right now we include the connectors as well with the price, because we said we want you to connect to everything, and then that makes you buy more tags. So we kind of like that from a sales perspective. Okay, so this is pretty cool. This is a company that we did work for in Alberta, and they wanted a water report, and where it came from originally was last October, I had gone and presented to one of my integrators, and they said, we don't know if we really have a solution for you. We're gonna look and we'll think about it. And he called me up 2 hours later and said, our customer just saved over their October report with their November start of data. So they just blew away the October report. It's gonna take them like, I don't know, day and a half to rebuild it, because they have to go out and figure out where the data is all coming from. Cool. So they had an Excel spreadsheet that had 80 macros in it. So they gave it to us. Took you guys about 2 weeks to build this up. So about 2 weeks they built this up. What's interesting now, this is part of core product. So it's available to you. You can just make use to it. You basically just connect all your tags that we just saw browse in. You just connect it into the report, and then it does all of your water reporting for you. Our full intent is, and if you have opportunities for it, we want to map all the standards. So oil and gas, API 21.1, which is the flow computing. In Canada, it's called Directive 17, which is a superset of API 21.1. But any reports that you have that are government required or agency required or those types of things, we'd like a chance to talk. Solar, those types of things. And if you have to submit reports, it's a nice, easy way, and we're willing to help build those. If they're really complicated, we might charge you some money for it. If they're not too complicated, we'll just do them for you. Yep. So these are just some sample dashboards. Pretty easy, very good trending, very capable. The other thing is it's really cool is we can do, on the x-axis, we can do multiple dates on the x-axis. So if you want to compare this year's data versus last year's data, we can handle that. So oil and gas, they have a well starting up, and then they want to compare the well next year to that well that was starting up, and they want to see how they overlay, or you have a pump starting up and you want to compare them. It's very, very easy for you to compare things at different time scales.
I did not know that.
Yeah.
Glad I got up in the morning.
Another thing that's really cool is alarms. The filtering on this is absolutely incredible, and you'll see as you click on something, so if you click on undervolt trip, it will actually yoke and adjust the entire screen to show you what all the data is for the undervolt trip. So as a centralized alarm management tool, there's really nothing else that can do this as fast, because we can connect to every SCADA system you have. And now with more and more regs, you're going to need centralized alarm management tools on bigger systems. You need to be able to just dump the data at the end of the month, say where all the critical alarms came from, all the safety alarms, all those types of things. And this will allow you to get them all from one place and align them all. And you can actually see what's happening if you're doing pipelines or things like that, or different gathering systems, that things are interactive. And KPIs. This is actually a shift report, more energy management. So we can do some really, really neat things. And all of these just are individual little widgets. You drag and drop them in, configure them. Here's a financial report. You can do forecasts and things on how much product you have left to consume. So there's a lot of capability involved in here. You can combine. One of the really cool things I like, you'll actually see up there, there's a filter up at the top. But you can combine your tables with your graphs. This becomes a printable report. You can even put a header on top of it if you want it to be a printable report, and you can put all sorts of addressing and stuff and things like that. It's the first real product I've seen that dashboards and reports are the same, or can be, which is very unusual. Most of the time, reports are one thing, dashboards are another thing, and you actually use different software products for dashboards and reports. And here's a final example. You can bring in JSON data and all sorts of other things like that. You can track trucks, do inventory management, all sorts of cool, interesting things. So, I mean, what we need from you is what are you imagining, and we'll help you figure it out. So cool. So knowledge is power. No code, no SQL. You can use SQL. We have SQL connectors. We have Mongo connectors. We have all sorts of other things. So if you want to get data from other places and just use an aggregator, then pump it out to whatever other multi-billion-dollar system you have it going to, that's fine. Dashboarding, reporting, supports industrial drivers, supports OPC UA and DA. And we actually have a connector that will connect onto VTScada that will convert OPC DA server to OPC UA. That's about $1,500. So, and all we've done is taken Itanta's capability and just kind of blocked off most of it and made it just a simple connector. We also have a point-to-multi-point connector that we can do with it. A little bit different than what Matricon does. ODBC server client, Mongo, calculation engine, numerous REST interfaces, you saw those. Supports mobility view. They've got a guy that runs a cookie factory, the CEO. What did he take? He took his efficiencies from, they were like 35% downtime or something like that. And then the CEO got a hold of Itanta, and they automated a few plants with Itanta. And their downtime at each of those facilities went to like 14% or something. Yeah. And that was just because he knew where all the bodies were buried. Something broke, he'd tell somebody, we know something over there has that, and so all of a sudden a whole bunch of things changed. Supports cloud or prem, and now Linux. So you can take one of these, put it on a little Linux box, like a Raspberry Pi, or we sell Zeta Edges. You can dump it out in the field and have it collect, and then it'll aggregate everything back to Itanta. So you can do some really cool, neat, interesting things. So, overlap of Itanta and VTScada. When do I use Itanta and when do I use VTScada? First of all, it's philosophy. You need to figure out what your philosophy is. What data do you need to protect? How important is it? Is your data critical? Do you need redundancy in places? Do you need people not fat fingering stuff? Those kinds of things. And again, you could put VTScada inside and outside, but there's a much bigger training curve typically to VTScada to do things. Itanta, less training and different skill. VTScada, typically you'd focus on operations. On the enterprise side, it's a little more interesting to teach people how to access everything. We have lots of people who use it for operations. We don't have many executives using VTScada. We have lots of people using Power BI. Itanta visualization, especially across multiple systems. So if you need to do alarm aggregation, data aggregation, or for systems like Factory Talk's a good example. It doesn't do gas well data, historical data very well. It doesn't do anything that speaks kind of DNP3 or Modbus or any of those kinds of things. So it allows you to do a sidebar end run on that whole system. They can still get critical operational data, but we can get all that historical data and all those cool things, MQTT or that type of stuff from around it. Where is your one source of truth? It's not the same place for everybody. Sometimes it's in the SCADA system. Sometimes it's in the DCS. Sometimes it's at a higher level in Pi. So you got to figure out where your organization says this is always true. How fast does it need to be? Do you really need millisecond data, or can you have historical data? Do you need millisecond alarms? What do you need to do with that, right? There's a whole bunch of other stuff, IT infrastructure, things like that, Cisco Works, WhatsUp Gold, all those kind of things you can start to aggregate. And where do you want to experiment? Do you want to experiment in your mission-critical SCADA system? Or do you want to let the newbies play in the top end in something that you can actually work with? Cool. I think that's it. So these are just some key partnerships. So this is just a thanks to the people involved in this. So it doesn't take a village, but we built one. So we had Lee and Chase came up and spoke. Itanta, Harshad is here. He's the Chief Technology Officer. If you have questions, both Ali and Harshad have their laptops here. I'd love to show you live demos. I didn't want to show you a live demo in front of here because sometimes it's not much fun watching people poking keys. I'm the president of BetSam Controls. Ali Reza, my VP Ops, is here. Pat Cook, he is whatever he wants to. He is whatever he wants to be, yes. Tyler Wheeler is in the back here. He's our support manager, and he's a VTScada specialist. And I got Bill Torvey as well. He's not in the room here. So I have quite a small army of people down here. Okay, thank you, everybody.
Okay, thanks, guys.